Hey guys, it's Mr. Rysz here. So if you didn't know, this is going to be my third attempt recording this video. The audio seems to be messing up sometimes, so I'm just double checking right now. I see the little green light moving up and down. You should be able to hear me. So let's get this started. This is calculus. We got P2 part 2 here, or no, P1 part 2. We're going to be looking at the points of intersection of a graph. So the points of intersection of a graph is a point, or in case points, that satisfy both equations. So remember, a point has an x and y value. If you plug it in, it would satisfy the first one, and if you plug it in, it would satisfy the other one. A lot of different ways we can find this. The easiest way is graphing, but what we're going to do first is to do this algebraically, and then use a graph to verify your answer. So probably the easiest way to solve any system of equation is to use substitution, meaning take one of the equations and get a variable by itself. So what we can do here is maybe get this variable, get the y by itself. We could get the x or y by itself over here as well. But I'm going to use this one here, get the y by itself. So if I get the y by itself, I get a negative y. I'm minusing the x squared over. So I get a y equals negative x squared plus 3 on divide by negative 1. And I get an x squared minus 3. So what we're going to do now is to take that, plug it right into there. So we take substitution to get one variable by itself and plug it into the other equation. So when we do that, we get x minus, not y, but x squared minus 3 equals 1. Oh, this is kind of messy. Should have did it the other way, but oh well. And when I distribute the negative, I get x minus x squared plus 3 equals 1. So I look at here, I have a quadratic equation. Quadratic equation, you always want to make it equal to 0. So and put the terms first. So this would be a negative x squared plus x minus that 1 over plus 2 equals 0. And the other thing about quadratic equations is if you ever have a negative in front, change the sign of everything, make it positive. X squared minus x minus 2 equals 0. Hopefully you guys can hear everything in the room. All right, so we got to factor this. What two numbers multiply together to give us negative 2, add together to get negative 1? That would be an x minus 2 and an x plus 1. We'll solve both of those. What minus 2 equals 0? Well, that's when x equals positive 2. What plus 1 equals 0? That'd be a negative 1. So what we just did there is we found out that x is one of the solutions, negative 1 is another solution. So we're going to have a point that's at 2 something and negative 1 something. Now to find that something, what we need to do is to take those answers and plug it back into one of the original equations. What we can also do is plug it into the one that we got the y by itself, which is nice because we'll just get the answer here. So I'm going to take 2, plug it in here. So y would equal 2 squared minus 3. That'd be 4 minus 3. That would be 1. So when x is 2, y would be 1, and that would work for both equations. And then we'll do the same thing with negative 1.
You don't have sunglasses on.
Negative 1 squared minus 3. So negative 1 squared is 1. 1 minus 3 is negative 2. So that's at 1, negative 2. And so the easy way we can check those two answers, 2, 1, negative 1, 2, is just graphing. So let me clear all my drawings here, and I'm going to open up Desmos. I can. Desmos, and type those equations in. Start graphing. So we had, I already forgot, what was the x squared minus y equals 3. Oh, I didn't put square. And then x minus y equals 1, I think. Yeah. Click on the graph here. Desmos does an awesome job locating those. So 2, 1, negative 1, 2. So that's how we can verify our answer. Okay, now to finish the notes here, we'll go through this pretty quickly because this year we'll be cutting out this section, or we'll be abbreviating it here, but mathematical models. So remember, like real life applications of mathematics often use equations as mathematical models, meaning like most of the time, especially in this figure here, real life situations don't follow an exact line or an exact equation, but it's something close enough. And we can use that information just to predict. So keep in mind when you read story problems, like, okay, what is the independent variable? So what would be the number you plug in? So like in this case, the time would be t is in years. And then what's your independent variable? What do you get as a result? And so in these problems here, they talk about carbon dioxide levels. So there's really, I don't think you have to worry. In fact, let's look at the CYU that you guys have to do for this section. CYU2, I think. We're eating breakfast this morning. So in the CYU, all you need to do is just points of intersection. So if you want, you can just pull up Desmos and find those. All right, guys, hopefully this video worked out well. Hopefully you watched it, and hopefully you have a great day. Have a good one.